Welcome to aminacademy.com. In advanced calculus regarding limit of sequence, let us do some solving problem. Look at this. Write the first four terms of the sequence. Look at here. The first nth term is given as 2n minus 1 over 3n plus 5. Let us give n equal to 1. n equal to 1 means the first term is 2 into 1 is 2 minus 1 is 1 over, then 3 into 1 is 3 plus 5 is 8. First term is 1 over 8. The second term 2n, that is 2 into 2 is 4, 4 minus 1 is 3 over 2 means 2 into 3 into 2 is 6, 6 plus 5 is 11. Then third term 2 into 3 is 6, 6 minus 1 is 5 over 3 into 3 is 9, 9 plus 5 is 14. Then of course next one is 7. Here this 4 is 3 into 4 is 12, 12 5 is 17. Like it goes. Next one, 1, the nth time is 1 minus of n power n over n square. Here n is 1. n is 1 means minus 1 power 1 is minus 1. So minus of minus plus, that is 2 over 1. Next is n is 2. n is 2 means minus 2. Here n is 2. Here n is 1 means here 1, that is minus 1 of minus 1 is minus plus is 2 by 1. If n is 2 means 2 minus 1 power 2 is positive 1. 1 minus 1 is 0 over n squared is, of course, it is 0. Then third is n is 3. n is 3 means power minus 1 power 3 is minus 1. Minus 1 plus 1 is minus of minus 1 is plus, that is 2 over n is, here n is 3. 3 means 9. Then fourth term n is 4. 4 means minus 1 power 4 is 1. 1 minus 1 is 0 over, here n is 4. That is 4. 4 is also 0. Like it, there is. Check one more time. Here n is 1 means minus 1 or 1 is minus 1. So 2 over 1. n is 2 means minus 1 power 2 is positive 1. 1 minus 1 is 0. And third is n is 3 means here minus 1, that is 2 over n is 3 means 9. 3 square is 9. n is 4. 4 means here positive. So 0 over, that is 4 is 16, 0 itself. Next here, look at here. 3 over 8, 5 over 7, 5 over 11, 7 over 14. Here the numerator increases to 2. That is first term is that 4. The continuing term is 2 to increase 9 over denominator increases 3. 14 plus 3 is 17. Next is 2 increases means 11 over 17 with 3 increases 20. Next here 11, 2 increases 13 over 3 increases 23. Next here another 2 increases 15 over 3 increases 17. Then next one 1 over 3, 1 over 9, 1 over 27. Next is of course this 3, 9, 27, that is 3 power 1, 3 power 2, 3 power 3. Like 1 over 3 power 4 is 81. Then next is 1 over 81 and 3 is 243. Next 1 over multiply with 3 is what? 9. 3 fours are 12. 1 carries 3 twos are 6, 7. Next is 1 over 3 nines are 27. 2 carries 3 twos are 6 plus 2 is 8. Then 3 sevens are 21. Next is evaluate limit n tends infinity 3n square minus 7n over 5n square over 3n minus 5. Look at here. Here, if you put infinity, it will give infinity over infinity. We cannot, as it is, supply the infinity for n. So, divide numerator and denominator by highest power is n square. What happened? Which gives limit n tends infinity 3n square by n square is 3 minus 7n by n square is 7 over n. In denominator 5n square over n square is 5, 3n square over n square is 3 over n minus 5 over n square. You apply the limit for n equal to infinity. Look at here, it is 7 over infinity is 0, therefore 3 minus 0 over 5 plus 0 minus 0, which is equal 3 over 5. Next, look at here. Here, limit n tends infinity, n into n plus 2 over n plus 1 minus n cube over n squared plus n. First, limit n tends infinity, LCM of denominator is n plus 1 into n squared plus 1, then by of is n squared plus 2n into n squared plus 1, then minus n plus 1 n cube. Here, opening the bracket, limit n tends infinity. Here, n squared plus n squared is n power 4. N squared plus 1 is n squared plus 2n cube plus 2n. Here, minus n power 4 minus n cube over n cube plus n square plus 1. Now simplify. N power 4 cut. Then 2n cube plus n cube plus n cube minus n cube is n cube only. That is here 2n cube minus n cube. Then n square is n square. Then 2n plus 2n over n cube n square plus n plus 1. Now here highest power is n cube. So multiply and divide by n square. That is n cube. So what happened? First, limit n tends infinity. Here n cube by n cube is 1. plus n square by n cube is 1 over n plus 2 over 2 over n square over 1 plus 1 over n plus n cube we are getting plus 1 over n square plus 1 over n cube. Now applying the limits, that means it becomes 1 over n becomes 0 because 1 over infinity is 0, 2 over infinity square also 0, here 0 everywhere. Then 1 plus 0 over 1 plus 0 plus 0 plus 0, which gives 1. The limit value is 1 for this expression. Next one, limit n tends infinity square root of n plus 1 minus square root of n. As it is, if you apply the limits for n equal to infinity, it will become infinity. So you have to rationalizing, which means multiply and divide by this factor with plus middle, that is n plus 1 minus square root of n over 1 into square root of n plus 1 plus square root of n over square root of n plus 1 square root of n. Look at here, then limit n tends infinity. Here a plus b, a minus b expression which gives n plus 1 minus n over, because this square minus this square, then square root of n plus 1 square root of n, which gives limit n tends infinity is cut 1 over square root of n plus 1 square root of n, which gives now here, which gives 0. This limit gives 0 because here you apply n plus 1, that is infinity, plus 1 is infinity, square root of infinity, infinity plus here denominator have infinity, 1 over infinity is 0. So far we discussed about limit of a sequence with different types of examples we have done. Please subscribe our YouTube channel.